Every day, millions of barrels of crude oil travel across continents. They journey in pipelines, on massive ships, and inside sturdy train cars. But few people actually know about the invisible chemistry making this possible. Behind the scenes, special chemical additives quietly do their work. Without them, moving oil could be a disaster just waiting to happen. Imagine raw bitumen, thick, sticky, and sometimes even explosive, sloshing inside a cold metal pipe. Without the right chemistry, it can clog, freeze, or even burst the pipe. Explosions and spills are real risks. It's not just about moving a liquid, it's about controlling a dangerous substance. This hidden science is both fascinating and honestly vital. Chemical additives turn risky crude oil into something manageable and safe. They are the unsung heroes of global energy. Even though we can't see them, our modern world depends on their secret work. In this essay, we'll uncover these chemical marvels. We'll see how they transform crude oil from a hazard to a harmless flow, keeping the global economy running smoothly. Crude oil straight from the ground is wild and unpredictable. Its vapor pressure is high, which means it can easily turn from liquid to gas. This makes it prone to forming dangerous fumes. If unchecked, these vapors may explode with just a tiny spark. Another problem is how crude oil behaves in cold or changing temperatures. Some oils turn solid, forming waxy crystals that block pipes. Others become so thick they stop flowing entirely. A frozen or clogged pipeline is a disaster for energy companies and the environment. When chemical additives are not used, these raw properties become threats. Pipelines can rupture from pressure buildup. Ships might spill oil if the cargo expands suddenly. Trains carrying crude may derail from frozen heavy loads. We have seen real accidents in the past, and the results can be catastrophic. The world learned these lessons the hard way. Today, chemistry is at the heart of every safe oil journey. Additives are no longer just helpful, they are essential. Inside a pipeline, oil moves like thick syrup. Every bump and twist in the pipe slows it down. This not only wastes energy, but also makes the journey longer and riskier. Enter drag reducers, tiny molecules that act like invisible ball bearings. Drag reducers are long-chain polymers. When mixed into crude oil, they slip between the oil molecules, smoothing the flow. Oil glides through the pipe with less friction. This means pumps need less energy and pipelines can run faster than ever. Think of skating on ice versus walking on gravel. Drag reducers turn the gravel of sticky oil into a smooth ice rink. This saves millions of dollars in energy costs. It also reduces the chance of pressure spikes that could burst pipes. Without drag reducers, the world's oil pipelines would be slower, more dangerous, and much more expensive. Thanks to chemistry, we can move more oil, more safely than ever before. In winter, some crude oils threaten to freeze solid. Others form wax crystals that clump together, blocking pipes and valves. This is where pour-point depressants step in. They are chemicals designed to keep oil flowing, even in freezing cold. Pour-point depressants work by interfering with how wax crystals grow. Usually these crystals stick together and form big blocks. Additives attach themselves to the crystals, keeping them small and separated. The oil stays liquid and smooth. Imagine trying to stir a pot of honey left out in the snow. It turns hard and impossible to pour. Pour-point depressants make sure the honey, or oil, never gets too thick no matter how cold it gets. When these chemicals are missing, pipelines freeze, oil stops moving, and entire regions can lose their energy supply. They are a silent shield against the bite of winter. The real test of chemical additives comes during extreme weather events. Back in 2014, North America faced a so-called polar vortex that plunged temperatures far below zero. Pipelines risked freezing, but thanks to pour-point depressants and drag reducers, oil kept flowing across thousands of miles. Now, in the Middle East, desert heat causes other issues. High temperatures can create dangerous vapor pressure inside tanks. Volatility stabilizers are used to keep oil calm, preventing sudden releases of gas that could ignite. There have been times when additives were not used or maybe misapplied. In 2013, a train carrying crude oil derailed and exploded in Lac Mégantic, Canada. Investigators later discovered the oil's volatility was not properly controlled. The result was tragic. Dozens of lives lost and a town destroyed. These examples show just how serious the risks are and how effective modern chemistry can be. When used correctly, additives shield us from disaster. One of the most dangerous features of crude oil is its volatility. That means it can turn into explosive vapor quickly, especially when heated or shaken during transport. Volatility suppressors are specialized chemicals that solve this problem. These suppressors work by binding to the most reactive molecules in crude oil. They stabilize them, making it much harder for the oil to turn into dangerous gas. By lowering the vapor pressure, these chemicals keep oil safe inside tanks and transport vessels. On tankers and trains, volatility suppressors are mixed in before the journey starts. They are monitored throughout the trip using sensors. If the risk climbs, more is added automatically. This chemical seatbelt is crucial for safety. If these additives are skipped, the consequences can be deadly. Unstable oil can explode with little warning. Volatility suppressors turn every barrel of oil from a ticking time bomb into a safe, manageable cargo. The latest revolution in oil transport is the use of artificial intelligence. Pipelines and tankers now have sensors that collect real-time data on temperature, flow, and pressure. AI systems analyze this data and decide exactly how much additive to use and when. For example, if a cold front is coming, the AI will inject more pour-point depressants automatically. If sensors detect a rise in vapor pressure, volatility suppressors are added right away. This precision means chemicals are never wasted and safety is always maximized. AI can spot problems before humans even notice them. It can also adapt to new types of crude oil, which may behave differently than expected. These smart systems make global oil transport safer and more efficient than ever before. With AI, the chemistry behind oil transport is no longer a guessing game. It's a precise, high-tech science that keeps the world's energy moving reliably. Every flight, car ride, and warm home depends on oil delivered safely from far away. The secret chemistry behind oil transport is not just about industry. It touches all our lives. Without these additives, whole economies could freeze, explode, or grind to a halt. Chemical safety in oil transport also protects the environment. Fewer spills, explosions, and leaks mean less harm to wildlife and people. This invisible work shapes everything from gas prices to air quality. New technologies and better additives make it possible to reach even the toughest oil reserves. They also help us use energy more efficiently, reducing waste and emissions. The impact is huge, even if most people never see it. In a world that never stops moving, the hidden science in every barrel of oil is a silent partner in our progress. When we think of oil, we picture black liquid and metal pipes. But what really makes modern life possible is the chemistry we never see. Chemical additives transform crude oil from a dangerous substance into a safe, reliable energy source. From drag reducers that speed up flow, to pour-point depressants that stop freezing, and volatility suppressors that prevent explosions. These are the real heroes. New AI systems make the process smarter and safer every day. Without this hidden chemistry, oil transport would be slow, risky, and costly. Our cities, industries, and homes would be at constant risk. Thanks to science, we can use the world's energy safely and efficiently. Next time you flip a light switch or ride a bus, remember the secret science making it possible. Invisible, but essential. These chemical marvels keep our world in motion.